Today I want to talk about the secure handling of confidential data in Kubernetes. There's actually a very good reason why I have chosen that topic. The reason is that I was once consulting a customer. That's quite a story I want to tell you first. And at supporting that customer, migrating their workloads into the cloud, I found a Docker Compose file. A Docker Compose file managing the whole production keycloak instance, containing all identities that provides access to critical systems. And within that Docker Compose file, the keycloak admin password was in there, checked into the VCS. And in my job, unfortunately, I have seen dozens of stories like that. I'm from AOE, and I'm consulting my customers migrating into the cloud or optimizing their workloads in the cloud. And luckily, none of my customers had yet been exposed, but Tesla can tell a different story. It's not that long ago where attackers have been infiltrated Tesla's Kubernetes and gained access via a Kubernetes secret to their AWS accounts. And the attackers actually were able to crypto mine on Tesla's AWS account. A very cheap way, I think. So you definitely don't want to do that with your project. Therefore, Kubernetes has a mechanism, so-called Kubernetes secrets. It's meant to handle confidential data for workloads. And I have one question: who has not yet been used Kubernetes secrets in their project? Is there anyone here? Nice. Everyone used Kubernetes secrets. That's great. I still want to talk a bit about details of Kubernetes secrets. So this is how they look like. We all know that. It's a simple Kubernetes resource similar to what a config map is, but the idea is that you separate your confidential data from the actual application configuration. And there's one very, very important point that a lot of people get wrong when they first use Kubernetes secrets. The value is actually not an encryption. It's just an encoding, and a lot of people really get that wrong. So keep that please in mind. And those Kubernetes secrets can be actually exposed to the application in two ways. You can either expose them via an environment variable to the application, or you can mount them as a file to the actual containers file system. The way of environments is the more convenient way. Nearly all applications support consuming secrets from the environment, but it actually has a higher risk of exposure. The reason for that is that it's easier to access environment variables on a compromised workload than it is to actually search for files on the file system. And you also have a risk of an accidental exposure, because most of the logs or debug outputs can contain environment variables. And I've already seen that a couple of times. Environment variables in logs or in debug outputs and containing secrets. That's not what you want to have. So file system is the more secure way. So you have a reduced risk of exposure. And you have another advantage with mounting file system. You can actually update secrets during the container lifetime. Since the mount is just changed in place, when the application is able to consume that and is able to watch for changes on the actual file, you can update the secret that has been used by the application while the container is running. Now let's talk about the downsides of Kubernetes secrets. Actually, Kubernetes secrets are not secure in any way. First of all, they are encrypted at rest. They are just a Kubernetes resource like a config map stored in etcd, and as long as soon as you have access to the etcd database, it's just a bold DB, you can actually read the secret out of that DB. The second important thing is that you do not have any advanced access control features in Kubernetes where you can fine-grain the access control to specific secrets. I will go through that a little bit later. And also, the deployment and management of Kubernetes secret resources can be really a daunting task. Since they contain confidential data, you cannot easily just check them into VCS, or some people are really doing that. You should not do that. And last but not least, they do not support any kind of secret rotation or expiration features. Let's talk about encryption at rest first. You want to avoid compromising your secrets from etcd. Luckily, Kubernetes provides us a mechanism for that, so-called encryption configuration. Basically, you can configure encryption for every Kubernetes resource, even though I would not recommend encrypting everything. It has a huge performance impact on the API server, but definitely consider encrypting secrets and also maybe config maps or other resources that can contain confidential data you don't want to expose. I don't drill into the details of encryption configuration, but a few points that I want to mention. The encryption configuration can only be used when it's enabled at the API server. So check out the Kubernetes documentation for that. And you should also avoid the identity provider. The identity provider, as you've seen it here, will be used then as a fallback. And the identity provider is just a pass-through provider. It does not do any encryption at all. And the last point, also very important, is that the encryption key that is used to encrypt your data should not resist in the cluster. Actually, the example that I'm showing here would contain the actual encryption key. You don't want to have that in your cluster. Consider of using the KMS v2 API, that's a feature from the Kubernetes API server, to reference to an external secret manager for the encryption key. There are also a lot of documentations out there which can help you with that. So going through the next point, limited access control. I have often seen access control like all or nothing. Either you have access to all secrets in a namespace, or you don't have any access. This is what I've seen a lot in the projects. The reason for that is that you have a very limited granularity of airbag policies. You can define an API group, you can define resources, and you can define some verbs. The problem is, in all of that, you can use wildcards and globbing, but when you want to drill down to a specific resource, to a specific Kubernetes secret, you can't use any globbing anymore. It's just a full name, it needs to match. So you can only define access control on a dedicated secret level or on a whole namespace level. And this actually often leads to a all or nothing policy. And what that means, I will show you here. This friendly guy, thanks to Dolly, by the way, is accessing one of your workloads via a remote code execution, for example, and this is all it takes to fetch every secret that the actual workload has access to. It's just 3 lines of bash script. wget and cat are installed by default on any Alpine-based image, so it's as easy as that. So you should use a proper ABAC to actually minimize the attack phase. You can't ensure that a compromised workload will expose a secret, but you can ensure that this compromised workload is not able to access any other secrets. So you should definitely follow the least privilege concept and define an RBAC role for each individual Kubernetes secret. Avoid generic roles like read all secrets in my namespace completely, and also do not create any consolidated Kubernetes secrets. I have also seen that a lot, Kubernetes secrets that are containing dozens of secrets for different use cases. You don't have an attributes-based access control where you can drill down on a field level. This means ensure you create secrets for each specific context. And last, a very warm recommendation: implement a policy engine like Kyverno or OPH Gatekeeper to ensure that those rules we just talked about are getting forced, actually. The next thing is about deployment and management of Kubernetes secrets. Since they contain confidential data, the question is how to actually store them. So every one of you is using Kubernetes secrets. Is there anyone in the room that is managing the Kubernetes secrets manually via kubectl? Oh, that's great. That's not what I've expected, actually, because I've seen that a lot on projects where we are stepping in when the shit hits the fan, and we are seeing Kubernetes secrets managed just inside the Kubernetes cluster with kubectl. And this actually is not a good idea because you lose the history. Reproducing your cluster configuration becomes really impossible, especially if you want to spread out to different environments. And your cluster state becomes really important in your DR because that's the single source of truth of your secrets then. The other really worst thing that I've seen is saving the confidential secrets in a repository in Git and just let them be. They really think I just give tighter permissions to that repository and then it should fit. It doesn't, because you have a really high risk of exposure of that secrets. They resist at rest, unencrypted in Git. They are transferred in your CI pipeline. There are so many points in the chain of deploying that secrets that can be exposed. So you definitely need to encrypt them at source level. And there are two tools which are quite common to use. The first one is called Sealed Secrets, and the other one is SOPs. It's a project from Mozilla. I personally would always use Sealed Secrets over SOPs. The reason for that is that they are pretty much giving you exactly the same standard of security, but Sealed Secret comes with less complexity and with a less operational overhead. So this is my recommendation. If you need to choose, go with Sealed Secret. Maybe you have SOPs in place already for any other use case, then it makes sense. But if you have to take the decision, go with Sealed Secrets. But still, managing Kubernetes secrets remain really uncomfortable and potentially less secure than, for example, with an external secret manager. Who is using an external secret manager? Now we are getting to the point. There are a couple of external secret managers out there. They give you way more flexibility in access control. You actually have a centralized secret store, which means you have a single source of truth. You don't have to scatter your confidential data across different systems. Auditability features, compliant features. I don't have to tell it to you. You guys know that. But the question is, how do I use that external secret manager in my Kubernetes? And of course, all the small tools, I just noted a typo, there's a T missing involved. All those tools have their own implementation actually to integrate into Kubernetes. But there are two generic solutions. They have kind of advantage that you abstract the way of how you work with the external secret manager from your Kubernetes. So you can change the external secrets manager, and it gives you much more flexibility. The first implementation is the external secrets operator. It's a community-based operator. And the other one is the secret store CSI driver, which is actually maintained by the Kubernetes 6 project. This morning you had a talk about Cosign. Exactly the same project is maintaining the Kubernetes secret store CSI driver. From my personal recommendation, I would always prefer the secret store CSI driver over external secrets operator. And there's two important reasons because of why I am preferring that. The external secrets operator comes with a lot of operational overhead. So you need to take care of that in your project. That's one reason. The other reason, which is more important, is that the secrets operator completely relies on Kubernetes secret resources. It just syncs secret from your external secret manager to Kubernetes. And then you have the same downsides as we just talked about, but just with an external secrets manager. And then you have two single sources of truth. You have replicated secrets, you have them in two stores, something that you don't want to have. The secret store CSI driver on the other side allows you to actually mount that confidential data directly into your container via tempfs. Pretty much the same as when you mount a Kubernetes secret value to the file system, but just without the need of having an actual Kubernetes secret resource. This reduces the risk of exposure a lot. You maintain your single source of truth, you don't have a replication, and these are two very important points. The problem, there's one downside. Most of the applications do not support reading or consuming their confidential data from a file system. Most of the application, and this is also what the 12-factor app says, read it from the environment variable. It makes you flexible. I mean, you can use the secret store CSI driver to actually sync Kubernetes secrets if required, but then again, you have the issue of all those downsides of Kubernetes secrets. So there is a hack which you can actually use to still use external CSI driver, load the environment variables, and not use a Kubernetes secret for that. It's very hacky, but it's a pragmatic way. One thing to mention, if you're going to think about that, please don't do that manually. You should consider using Kyverno or any other mutating policy engine which can actually automate that for you. And how that works is pretty simple. I mean, you see that. We just loop over mounted secrets in a specific directory, export them into the environment, and then we actually start the actual application command. But is there a non-hacky way to do that? And yes, there is, especially when you're using HashiCorp Vault. I'm a bit opinionated, I think. You guys have already noticed that in the last couple of slides. I would, by the way, always prefer using HashiCorp Vault over any other tool. We've been using this for, I don't know, 6 years now, maybe more. It's a really cool tool. It gives you a lot of flexibility, and in combination with a tool which is called Vault Secrets Webhook, you actually get the most secure way of using environment variables or secrets in environment variables. The Vault Secrets Webhook is a project from Banzai Cloud. It's part of kind of a bigger product which is called Bank Vaults. It gives you a lot of additional features on top of Vault, and It's open source, it can be used, it does not cost anything, and it gives you actually the ability to define a key reference to a secret in Vault in your environment variable, and that reference will be resolved when the container starts, not before. This actually ensures that your secret is only available to the process where the application is running in. Even though when you have a remote code execution, start a sub-process to inject some shell stuff, these secrets are not available just for the process. And they are all kept in memory. There are a lot of additional features in that webhook which ensures additional security around Vault. So this is really my personal recommendation. So let's do a kind of a sum up, a conclusion. In general, keep in mind, Kubernetes secrets are not secure, they are not encrypted at rest. Independently of if you are using Kubernetes secret resources or not, configure encryption for them. You never know when someone is using them. Define proper RBAC with a least privilege concept behind it. Create a Kubernetes secret an RBAC role for each Kubernetes secret resource, and use a policy engine like Kyverno or OPA gatekeeper to actually force the compliance to the above. Regarding secret management, you should definitely follow the security best practices depending on the provider you have just selected. For small and medium-sized or small projects, you can really go for sealed secrets. That's a good solution, that's a secure solution, that's a pragmatic solution. But for larger projects, definitely consider an external secret manager. It boosts your security, it boosts your flexibility, and it's a really convenient way of using secrets. Yeah, last but not least, HashiCorp Vault. Again, my personal recommendation, go with HashiCorp Vault in combination with Vault Injection Webhook. That's the best way you can use secrets. I have outlined a decision tree, which should help you guys when you are searching for a solution with a decision on which solution you want to go. It's hardly readable, I guess, but I think you can still watch the video afterwards and maybe zoom into it a little bit more. Yeah, that's about it. We still have a couple of minutes for questions, I guess. And yeah, you can definitely also contact me afterwards if you still have questions.
Thank you so much. We have two questions, at least for now, because I see there's more coming up. Why not using CSI environment sync feature instead of for loop export?
I'm not sure if I understand that question correct. So the CSI env-sync feature does not sync it directly into the environment, right? So as I understand, or as I know it, it just replaces the secret in the definition, but I can be wrong here.
If using Vault secret webhook, does the application actively must read the secret from Vault? Then does it need the capability to do so?
Does it need to? Yeah, so I think the question is around how does the actual workload authenticate against Vault? The answer is pretty simple because it uses the workload service account, and you can define very fine granular policies in Vault to actually ensure that this workload can only access the secrets that are important to that specific workload.
I told you we have tons of questions. That's pretty cool.
Yeah.
Another one. Assuming an infrastructure without Kubernetes, only using Docker, what would you recommend to manage secrets?
Only using Docker without Kubernetes. I would still go for Vault, actually. There is an additional tool which is called Vault-Env. And Vault-Env is actually be used from the Vault Secrets webhook underneath, and is actually doing the job of replacing this secret reference with the actual secret.
Okay. Next one, how do you rotate properly secrets with still secret operator?
Yeah, that's a huge question. And I actually thought about of having a secret rotation as part of that talk, but I quickly realized this topic is so huge, and I can't really give you an answer in a short manner right now.
Perhaps then they can reach out to you after the session.
Yeah, of course. Yeah.
All right. Would you recommend the Vault injection webhook over the native HashiCorp injection that works via annotations?
Yeah. The short answer is yes. The long answer is that the injection webhook does pretty much work as a sealed secrets operator. It syncs the secrets or injected directly into the specification, and the Vault Secrets webhook gives you the ability of resolving it just for the actual process of the application, which gives you the highest security level you can achieve.
Have you heard about Vault Secrets operator saying secrets from HashiCorp Vault? What is your opinion about this? It's also related, I think, to the last question.
I think it's pretty much the same question, right?
Yeah. How to handle access to the secret store from the CSI or operator? Does this need some kind of RBAC also?
Yeah. So the external secrets operator is handling the access depending on the actual secrets manager you're using. In terms of Vault, the external secrets store CSI driver uses as well the service account for that. So you can drill down very nicely to limit that.
Are you using Vault Secret webhooks also for third-party applications like Ingress Controller or just your own ones?
Yes, also for every third-party application that we are using. It just makes things easier if you have the same way of doing it across your whole platform. And since it's just a key that needs to be put into an environment variable, it's very flexible and you can actually use it for all applications. So we have not yet had an application which was not compatible with it.
Okay. One of the two last questions, sorry. Are you operating the secret managers yourself? We always had issues operating Vault in physical. Oh, in physical was the question that I had afterwards. Yeah. Which one was a killer for implementing it for all clusters?
Yeah. We also have issues when we operate Vault by ourselves. Vault itself is not a big deal to operate, but the highest or the critical problem on my perspective is a kind of a chicken-egg thing. How do you provision the Vault? How do you get to that point? Where do you store the secrets before Vault is up and running? But HashiCorp has a cloud where you can actually host Vault in a cloud in a secure way. Consider using that. It's much more easy and it does not cost very much.
Cool. External secrets operator wasn't mentioned, which is one of the ways to get secrets from external secrets provider to cluster secrets. Any specific reasons?
I actually mentioned it. You might have briefly heard it. I just said that I would always prefer the external secrets CSI driver over sealed secrets operator. And the reason is actually because the operator relies completely on Kubernetes secret resources. And we just learned what the downsides are.
if I can add one personal question.
Of course.
I often see the physical software as a HashiCorp Vault alternatives, especially since the day that HashiCorp has been acquired by IBM. Have you evaluated in physical? Do you have some
No, not yet.
feedback for that?
I don't have any experiences in that, unfortunately.
Too bad. Okay, we are a little bit ahead of our schedule, but that's fine. Thanks a lot for this very interesting session, and thank you all for the great questions.
Yeah, thanks for listening.